Hello, everybody. My name is Derek Moore, and I'm joined by Simon Schoenbeck, and today we're going to be going over our project, the Labor Market Machine Learning for the Nebraska Department of Labor. So the company we sponsored with for this is the Nebraska Department of Labor, and they are tasked with anything related to labor for Nebraska, including labeling job titles, anything relating to labor statistics, and those sorts of things. And our group, our main goal with this was to standardize job titles for the state of Nebraska. And we are given about 100 million or so a quarter, or the Nebraska Department of Labor is. And our goal with this project was to create something that would not only be more efficient than a human, but also be more cost effective for standardizing jobs across the state of Nebraska. So the stakeholders for this presentation included Dr. David Rosenbaum here at the University of Nebraska-Lincoln. He is the department chair of economics, and he is the main person that will be running the application that we created. And then we have the folks over at the Nebraska Department of Labor, including Andrew Bowens, Scott Hunziker, Brandon Jones, and Kermit Spade. And they were with us throughout the course of our release meetings, ensuring that we were meeting their expectations throughout the development. And then we have our team. Our team consists of Bill Browning. He was our project manager for this year. Dr. Shruti Bowman, the tribe lead. Myself, Derek Moore, the squad lead and project manager. Simon Schoenbeck, the development manager. And then Garrett Beard, Will James, and Isaac Werner as the developers. So like I stated earlier, our group was given 3 problems that we needed to solve throughout the course of this year. The first problem being that end-all labels over 1 million job records with standardized codes each quarter. And so the opportunity our group had to solve this was to find a more suitable solution for processing large amounts of data. Another problem was that the existing solution, which was created by a group last year, was inefficient and used depreciated technologies. So our group had the opportunity to update the front end of the application to use up-to-date technologies. And then the last problem our group had the opportunity of solving was outdated versions of standardized codes. And we had the opportunity to update those from the 2010 codes to the 2018 codes. And I will now pass it off to Simon for going over the application as a whole.
So our main source of labeling came from Amazon Comprehend. Amazon Comprehend is a machine learning platform that allows users to train and implement text-based classification, which is the problem we're trying to solve. So we take in the data as a file, a CSV, we parse the string, and then we get a label out, and then end-all wants this label stored back on the same row of the CSV that we were given. Machine learning is a good application for this because lots of data could be slightly different, and a standard system in a database might not handle errors like spelling mistakes or illegible handwriting. So machine learning is a better solution for that. We also used batch processing, which allows us to handle much larger file sizes and lots of entries all at once, as opposed to like real-time labeling. Since we were using Amazon Comprehend, we continued using AWS, Amazon Web Services, and for the other options and services for linking into their backend. So we use Amazon S3 for data storage, storing files. We used AWS Lambda for running functions that are executed only occasionally. or event-based. And these are for data manipulation and transferring files between S3 buckets. And then for user interaction, we needed to host a website for a user to interact with. So we used an EC2 instance, which hosts servers automatic, which is an automatic server hosting application through AWS. And then for the front end, we built that in Vue.js. So that was just a system we built. And then here is our full architecture diagram. We can see on the left, a end-all user connects using MFA and a login to the web application hosted on Amazon EC2. And then a file is passed through a series of buckets and Lambda functions, which split the file if it's too large, pre-process it, which makes it prepared for processing, make sure all the data is cleaned and in the right format. It's sent to the temporary bucket. Inference can pick it up, create a batch process. When this whole system of cleaning the file and splitting it only takes a few seconds, but then we have to wait for the comprehend batch to finish. And so that can take tens of minutes. The result comes back, it's in the output. We post-process the file by taking the labels and appending it to the original file. And then this entire service is made more user-friendly because we connect it to an SNS topic, simple user notification service. And so this allows us to send a user an email whenever something either fails or whenever something successfully is labeled. So showing an example of the front end. Here is the most important window for someone to look at. So we have in the middle an upload button. So someone can select a file from the local machine and upload it. And then whenever something is finished labeling and the user has gotten an email, they can go and check, and it should be displayed. Most recent files are labeled at the top in this chart here. So moving on. Some value and highlights of our project. We were able to significantly reduce the runtime from last year's implementation. For a single 100,000 line file, we were able to drop the runtime down to 20 minutes. And this actually is limited by what Amazon Comprehend can handle. So they have a hard cap of how many lines you can give per amount of time. And so that limits us to 500,000 times, 500,000 lines. We can run that in 20 minutes. But trying to exceed that limit requires us to take a second batch for 20 minutes. So if you want to run up to 1 million lines, which is what Endall runs quarterly, it will only take 40 minutes. And this is down significantly from the 120 hours that last year's program would take. Additionally, we reduced cost by changing some Amazon settings. So we reduced the cost from $4,400 down to $1,200. This is yearly, assuming that same running time for both programs. Additionally, we maintained a 90% model accuracy, though it's difficult to push past this because of just data quality. If someone spells something wrong, that's on the human, and the computer has to learn that the file is a certain way. It's difficult to handle these special cases when you're up in the 90s% inaccuracy. Additionally, we were able to significantly increase the usability on Longevity website by updating to a Vue.js framework over the older legacy framework. And we were able to do all this through planning. We spent a significant amount of time selecting which are the most valuable tasks to prioritize. Those were selecting a good model and training it well, and also implementing very orthogonal code so that if we needed to change out a certain part, which we did change out the front end and we did change out the model multiple times, and we were able to do this by enforcing good code style and making orthogonal code so we can easily replace parts without affecting the entire system. So that was a quick overview of our system. Thank you for our presentation. If you have any questions.
If not, that concludes our presentation. Feel free to stop on by to our virtual table to see a little bit more of the application and talk with the team.
Great job, guys.
Mhm.